As the world races against time to tackle climate change, nuclear power is being touted as a potential game changer in the fight for a sustainable future. With its promise of zero-carbon electricity, nuclear energy could be the hero we desperately need. But with that potential comes the fear of catastrophic risks, waste management issues, and the looming question of safety. Can we truly trust nuclear power to solve our climate crisis? Or is it a dangerous gamble that could backfire in ways we can't predict? Let's dive in. Small modular reactors. Small modular reactors are compact nuclear reactors that can generate power in smaller units compared to traditional large nuclear plants. Small modular reactors offer significant advantages in terms of safety, cost, and scalability. Because they are smaller, they require less investment and can be built more quickly. In fact, the construction time for small modular reactors could be reduced by as much as 30% to 40% compared to traditional reactors. Countries such as the United States, Canada, and the United Kingdom are investing heavily in the development of these reactors, with companies like NuScale Power and Rolls-Royce leading the charge. NuScale Power's small modular reactors is expected to be operational in the U.S., marking a significant milestone in the commercialization of small modular reactors. These reactors are designed with enhanced safety features, such as passive cooling systems that automatically shut down the reactor in case of an emergency without the need for human intervention. Additionally, small modular reactors can be deployed in remote areas or industrial complexes, providing energy where it might otherwise be impractical to build large-scale plants. Advanced reactor designs. Alongside small modular reactors, advanced reactors like molten salt reactors and high-temperature gas reactors are also being developed to address the limitations of older reactor technologies. Molten salt reactors are particularly promising because they use liquid fuel, which has several advantages over traditional solid fuel in terms of safety and efficiency. High-temperature gas reactors, on the other hand, can operate at much higher temperatures, which allows for more efficient energy production and the potential to supply heat for industrial processes, such as steelmaking or desalination. According to the International Atomic Energy Agency, several countries, including China, Russia, and the United States, are experimenting with these technologies, and it's likely that we'll see prototypes in operation within the next decade. These advanced reactors are designed to be more sustainable by reducing nuclear waste and potentially recycling spent fuel, which could dramatically improve the long-term viability of nuclear power. The climate hero perspective. Nuclear power's role in emission reduction. Nuclear's contribution to carbon-free electricity. Nuclear power already provides a substantial share of the world's carbon-free electricity. Nuclear energy generates approximately 10% of global electricity and 20% of electricity in the United States, making it the second largest source of low-carbon electricity after hydropower. In countries like France, nuclear power accounts for over 70% of electricity production, making it the world leader in nuclear-generated power per capita. Canada, Sweden, and South Korea also rely heavily on nuclear energy to reduce their carbon footprints. China, which is rapidly expanding its nuclear fleet, aims to increase its nuclear power capacity to 58 GW by 2025, a move that will significantly contribute to its emissions reduction targets. These nations have leveraged nuclear energy to ensure energy security while simultaneously cutting back on carbon emissions, proving that nuclear power can be a critical ally in the transition to a cleaner energy future. Preventing greenhouse gas emissions. According to the World Nuclear Association, nuclear power is responsible for preventing approximately 2.5 billion metric tons of CO2 emissions annually. This is the equivalent of taking over 500 million cars off the road each year. The emissions reduction benefits are especially apparent in countries where nuclear energy forms a significant part of the energy mix. In the United States, for instance, nuclear energy prevents the release of nearly 700 million metric tons of CO2 every year, contributing to the nation's overall efforts to cut down greenhouse gas emissions. This level of impact makes nuclear power an indispensable component of any comprehensive climate strategy. If nuclear power were to increase its share of global electricity generation, the amount of CO2 emissions avoided could grow exponentially, making nuclear energy one of the most effective tools in combating climate change. Reducing global emissions by 6.3 gigatons by 2050. A report by the International Atomic Energy Agency suggests that nuclear power could reduce global CO2 emissions by up to 6.3 gigatons annually by 2050. This is a significant contribution, as global emissions need to fall by at least 50% by mid-century to avoid catastrophic climate change. By increasing the role of nuclear power in the energy mix, particularly through the development of advanced reactors and SMRs, the world could make significant progress toward achieving climate goals. The International Atomic Energy Agency's report emphasizes that nuclear energy can help meet the growing global demand for electricity while reducing emissions from traditional fossil fuel sources. For nations aiming to achieve net zero emissions, expanding nuclear power capacity is seen as an essential part of the solution, particularly as other renewable sources like wind and solar are intermittent and face challenges in scaling up quickly enough to meet future demand. The silent threat: concerns around nuclear power. Radioactive waste disposal. One of the most significant challenges of nuclear power is the management of radioactive waste. The spent fuel produced by nuclear reactors remains dangerous for thousands of years, and finding a safe and sustainable method of disposal has been a persistent problem. Currently, there is no universal solution for long-term waste disposal, although some countries are making progress. Finland's Onkolo repository, which is set to open in the 2020s, is the world's first deep geological storage site for nuclear waste. Located deep underground, it is designed to isolate waste from the environment for up to 100,000 years, providing a potential model for other countries. However, not all countries have committed to similar projects, and many are still debating the best way to handle nuclear waste. In the United States, the Yucca Mountain Repository, which was once proposed as a permanent storage site, has faced significant political and legal challenges, delaying any significant progress on waste disposal. Safety concerns and accidents. The potential for catastrophic accidents, like the ones at Chernobyl, 1986, and Fukushima, 2011, remains a major concern. While the nuclear industry has made substantial advancements in safety over the years, including the implementation of advanced reactors with fail-safe mechanisms, the public's perception of nuclear power is still heavily influenced by past disasters. For example, after the Fukushima disaster, many countries, including Germany, opted to phase out nuclear power altogether, fearing that the risks were too high. While modern reactors are significantly safer than older designs, incidents like Fukushima have led to widespread public mistrust. Moreover, in many parts of the world, the financial and political costs associated with building new nuclear plants are often seen as prohibitively high, especially when compared to the rapidly declining costs of renewable energy sources like solar and wind. That's all for today's video. If you found this deep dive into nuclear power fascinating, don't forget to hit that like button and subscribe for more thought-provoking content. Share your thoughts in the comments below. Do you think nuclear power is the solution to our climate crisis, or should we look elsewhere? Let's keep the conversation going. Thanks for watching, and we'll see you in the next one.